Hey everyone, this is Mr. Garguilo, friendly neighborhood science teacher, presenting live from the moon. Obviously just kidding, we're here at Sleepy Hollow. So you just watched the movie October Sky, and this is a talk about NASA, the future, and also about the characters that you see in October Sky. Well, first off, why am I presenting and why am I wearing this kind of weird outfit? So this is my flight suit from when I trained with NASA. When I was younger, I joined NASA for a little while to train to be an astronaut. NASA then canceled their flight missions, so I was unable to continue with them, and then became a science teacher. So interesting fun fact about NASA is when I joined NASA, I was signed on to be the commander. Just so you understand, it sounds really fancy, but really what NASA decided to do is they were part of the military when they first started. They were one of the Air Force, and they brought over Air Force pilots, and in a spaceship, you have to have a pilot and a co-pilot. Well, when they started naming all of the pilots, and some of them got named co-pilot, half of them quit. They said that they didn't sign up to be co-pilots. So therefore, NASA decided just to rename themselves. They named the pilot the commander, and they named the co-pilot the pilot. So I am kind of the pilot, is what I was trained to be, but they gave me the name commander at the time. And you see this in the flight seat of the orbiter and training in order to use all the systems. This is me with a flight simulation. This is one of the people that I trained with at the time, and we were doing extravehicular activity training at this time, so it was quite exciting at NASA. Well, one of the times I was at NASA, we definitely watched the movie October Sky. It came out just around the same time. So October Sky is based on a biography, which is a book called Rocket Boys. The reason why they changed the name from Rocket Boys to October Sky is at the same time that the book came out, there was a famous movie that came out called The Rocketeer. And they thought it was a little confusing. If they made the movie The Rocket Boys, they thought people in the movie theater would get confused, so they changed the name to October Sky. So one of the things that you saw in the movie is the real location of Colwood. Colwood, as you can see here, now has a sign that says it is the home of the Rocket Boys, showing that they are giving enough credit that literally they have their own sign in their own town, which is always exciting for anybody there possibly in the world. Well, this is the real Homer Hickam with the movie that you saw Homer Hickam playing his character. And Homer Hickam, excitingly enough, was one of my mentors and teachers when I was with NASA. So this is myself with the real Homer Hickam. And the day that I got to meet Homer Hickam, he gave me one of his books and he signed the book. And the reason why I got to meet him and have this special time, we spent an entire day together, and he went through a lot of training, explanations with me. You can see down here I'm holding his book that he signed for me. But you also notice around my neck there is a medal. That's called the Right Stuff medal. I was given the medal for Trainer of the Year with NASA when I was working with them, and Homer Hickam and I got to spend the day together, and he continued showing me lots of things and all the stuff that he did in the past. So it's very exciting to learn from Homer Hickam, and yes, he is still alive, and yes, he does still help NASA. So it's very exciting. So to talk about NASA and where they come, and this is really what Homer Hickam eventually helped to create. This is the visual that we know of as NASA. The space shuttle. The space shuttle was around for about 18 years, so essentially your entire livelihoods. You've seen the space shuttle. Well, before the space shuttle, there was this thing, okay, which looks a lot more like what we consider a rocket, especially when you're watching the movie October Sky. You're used to something more like this. This is the Saturn V rocket. This is the first rocket that we used to go to the moon. And so you can see, this is the little piece that's at the very top here. That's the only part of the rocket that returns to Earth. The rest of the rocket is completely burned up in the atmosphere. So to show you, we've gone from the Saturn V rocket to now using the Ares 5 rocket. This is the Ares 5 rocket. You'll notice that there's two of them. This is the Ares 1 and the Ares 5. Interesting fact about NASA. These rockets here, okay, the Saturn V, the reason why it's a Saturn V is Saturn 1, 2, 3, and 4 were failures. Saturn V was the first one that succeeded. So when they invented the new rocket, the Ares rocket, they decided to call it the Ares 5. Not because Ares 1, 2, and 3, and 4 failed, but because it was lucky number 5, so they decided to name it number 5. The reason why there are two rockets is NASA this time has decided that they are going to separate the astronauts from the payload, which is the stuff they're transporting. So this is essentially the robot-controlled rocket that is going to be sent into space. It will have all of the compartment and cargo in it. This is the one that has only one stage rocket booster, and all it's carrying is the astronauts at the top. So this one is controlled by humans, this one is controlled by robots. you may see on the news lately that NASA has been practicing a lot of drone flights, and that's because they're testing out this rocket here, the Ares 5. And you can see in comparison the size difference. So here's the space shuttle that we know of today with the little airplane-looking thing on the top. This is the Saturn V, the old version. These are now the two Ares 1 and Ares 5 rockets. So looking at a comparison between them taking off, okay, very interesting to see them. So NASA has essentially given up for a while they're saving up money and focusing on the task of getting to their next location, which is Mars, and they have now turned over all of their rights to launch into space to two companies. There is SpaceX, okay, and then there's also Virgin Galactic. They have two different goals. SpaceX is looking to eventually get minerals and resources from space and bring them back to Earth, where Virgin Galactic is attempting to become essentially a tourist or a vacation site for people that want to go into space. As instead of flying to Bermuda, you would fly into space on this little spacecraft here, which would completely fly back down to Earth. They have had many successful missions on doing so, and they're hoping that by the year 2020, traveling into space for vacation, and that doesn't mean you're going anywhere, it just means going up into space, coming back down to Earth, will become something in the future. And then there's also the Chinese National Space Agency. They have gained a lot of ground, they have already made it into space, and they are hoping by 2020 to also make themselves their way to the moon. So this is what their astronauts look like. So this is really the competition that America is facing, is the Chinese space program. SpaceX and Virgin Galactic are working with America, and they have a different goal in mind. Okay? So looking at NASA themselves, NASA stands for National Aeronautics Space Administration. And you'll notice that the red marker here goes outside of the circle. It used to go inside of the circle, except once we left our own solar system using some of our robots and satellites, we went outside of the solar system and they changed the symbol. So where is the future of NASA going? NASA is going to Mars. That's the goal, to eventually get humans on the Mars and colonize Mars as much as possible. In order to do that, NASA opened up a new group of people, which is called the JPL, the Jet Propulsion Laboratory. And I think a lot of you, if you're interested in space, interested in becoming a part of this as a future job occupation, the JPL is really something that you're probably going to be more inclined into being a part of. Being part of an astronaut, there's not many astronauts. Every year there's maybe 6, maybe 8, but as a JPL, there is about 200 a year, so it's a much more open area. So the JPL has a really interesting task. Their job is to take robots and eventually get them to land on other planets. And we've succeeded in this many times. If you've ever played darts before, where you take dart and you throw it at a board, if not, you really should, it's kind of a fun time, but it's a very difficult thing to get a bullseye on a dart. To allow you to understand how the JPL works is this. They have to take a dart and they have to throw it and get a bullseye on a dartboard. Now remember, the dartboard is another planet at this time, and the dart is a robot that is being thrown from Earth. Now to increase the difficulty of this, okay, not only is it far away, but the dartboard is traveling in space at about 30,000 miles per hour. In addition to that, you're on a location that's traveling at 30,000 miles an hour in the opposite direction. So you're trying to throw a dart at a moving target while you yourself are standing on a moving target. In addition to that, there's also obstacles in the way, such as asteroids, other planets, and moons. In addition to that, not only are you throwing a dart to the dartboard, you have to wait 1.5 years to find out if you actually did hit the bullseye, because that's how far away the dartboard is. To make it even a little bit harder for yourself, the distance is so far away that by the time your robot gets there, you can't even communicate with the robot using radio information. Because by the time you tell the robot to do something, the robot will have already had to have done it. So you have to build into the robot system all the information that is needed in order to land and do all the tasks that it needs to do. This is an incredible task that these mathematicians and engineers have to work on. Now, before you're like, wow, that must be a really boring job. As you can see, the JPL, it's a really good time. A lot of times, people go to NASA, NASA's more serious. You go to the JPL, and the JPL just seems like there's always a party going on. The engineers are having a great time. They're always high-fiving each other, excited about all the tasks they achieve, Because as I said, these tasks are incredibly difficult. So when there is success, everyone celebrates a success. Okay? And just to show you a couple of the robots that they built, okay, so you can see what the robotic systems look like in case you're interested in this engineering field. So this is Spirit, which is one of our rovers that is on Mars, still currently today. Here's Opportunity, which are they're twin robots that were sent at the same time. And this is from Spirit, looking at what Spirit sees on the surface of the planet. You'll notice that it looks very strange how it's like an oval lens called a fisheye lens, so you can see as far as possible around the rover. This is Phoenix, okay? And Phoenix was our last one that we sent. Phoenix was actually launched the day that I was married, and no coincidence, okay? So you can see Phoenix is a really big project. You'll notice that all of the rovers use solar power in order to power themselves. We are now down to only Opportunity. Spirit and also Phoenix, their solar panels were covered by Mars dust, and no longer do they get recharged at this time. There's always the day that a tornado can come by on Mars and blow them off, which happened with Opportunity. So we have good opportunity, I guess. So this is what Mars looks like on the surface. We have these images from our rovers. So this is a foreign planet. Now, you're like, why focus so much on Mars? Why not Venus? Why not Neptune? These other planets that are out there? Well, here's the reason why. Because Mars had water. And we know this for sure. As you can see here in some of the telemetry data that comes back, we were able to see that there was a river on Mars. Well, if Mars had water, and Mars, we believe, looked like this in the past, so here is what we considered Mars to look like 4 billion years ago, to current day now, what happened to its water? And if it had water, and we have water, how can we prevent our planet from becoming like that? So it's a really big deal for us to look at this. In addition to that, it does have an atmosphere, it is the right size, it has the right temperature, it is a livable planet. So we do have the ability to be there, we would just have to supply the water right now, which is a big concern. So you can see this is what they believe Mars to look like in the past, this is what it looks like today, so finding out what happened is obviously a major point. Now before you're like, wait a second, you said there's water and there's this ice cap up here, that was the main task of Phoenix, was to find out if that was water. Unfortunately, that's frozen methane, which means it's so cold up there that the gas was frozen in as an ice cap. Okay? So looking at the future and how NASA works. They work on 3 different areas. Obviously there's the science, which you're learning in school now. You need to know everything that has essentially been instructed and learned before in the past. Then there's the exploration, looking for the unknown, ideas that can solve something that we've never thought of. And then finally the technology. And we take all of these and weave these together to eventually get ourselves over to Mars. Notice also, along with Mars, it has its 2 moons, Phoebus and Deimos, and we're also interested in those 2 moons as they are potentially habitable. So these are graphical representations of what NASA would hope the future to look like, that we have astronauts on Mars. And you're like, really? When's that supposed to happen? NASA has slated 2020 to make the launch to Mars, that they would be getting there around 2022 or later in 2021, as it does take a year and a half to make the full journey over to Mars. So this is what they're hoping that future will look like with bases on Mars, eventually being able to terraform it, which changes it over. We hope to name the first base on Mars, Mars 1, and you'll notice that there's a human fingerprint in the circle here for the planet. Okay, a little creative design here. These are pods. This means that we would have to launch, each one of these is one of our rockets, so we'd have to launch that many rockets to get to Mars. This is obviously an ambitious goal. But the reason why I focus on this goal for NASA is because this is the goal that within your lifetime, there's a good chance that you'll probably see happen. Okay? And looking at what makes it a planet habitable, there's the habitable zone, which is there's too hot, like Venus and Mercury, they're just too hot. There's the farther ones out there like Pluto that are just too cold. Well, Mars and Earth are just in that right zone where it's just right, like Goldilocks. And they're actually referred to as the Goldilocks planets. You can notice that there are more than just Mars. We have many planets that are considered habitable. It's just a matter that they're further than our solar system, so it would take longer than 1.5 years to get there. And right now, 1.5-year car trip seems like a crazy thing to even think about, to let alone even get further into 30 or 40-year car trip and your little rocket ship. You can see that every day they start discovering more and more of them, and there's so many exoplanets. Exo means outside of our solar system. Planets are available. You're like, well, how many planets are there that are livable? I get this question a lot. Well, we don't really know. if we look at our Milky Way galaxy, this is where we live. This is our sun on the Milky